Hello, welcome to Algorithms. Today we are going to discuss about modern data platform architecture using Microsoft Azure Data Services. Now this is a very extensive architecture, and it is more of a unified data platform, and that can be used to meet most of the common requirements. For instance, traditional relational data pipelines, big data transformations, unstructured data ingestion and enrichment with AI based functions, stream ingestion and processing, serving insights for data driven applications, and rich data visualization. So, these are the five different common requirements from different dimensions which happens in any organization. Now, if you remember my first or second presentation where I spoke about Lambda architecture and the batch architecture in terms of big data, this presentation is going to help you go to a next level, that how do you really architect a real-time system with the products which are available on the Microsoft Azure data services or different services that you use, and then how do you define an architecture which is Lambda architecture, as well as more of a traditional architecture as well. As I said, there are five different dimensions that we will cover, but for your use case, things may vary, so you can pick up this reference architecture and tailor it according to your organization needs. Now, the relevant use case, I would say, is enterprise-wide data hub, and that consists of data warehouse for structured data and a data lake for semi-structured and unstructured data. So the data hub becomes the single source of truth for your data within your organization. Now the second will be to integrate relational data sources with other unstructured data sets with the use of big data processing methodologies, as I said, Lambda, batch, and so on and so forth. Using semantic modeling and power visualization tools for simple data analysis. So these are the different relevant use cases that you might have in your organization when it comes to using appropriate architecture. So let's have a look at it. So as you can see that from the data source perspective, we have relational database, we have semi-structured data, we have non-structured data or unstructured data, and we have stream data which is coming from IoT devices, sensors, and gadgets. Now we have taken a different path depending upon what type of data we are using and what is the end goal we are trying to achieve. Now in this case, basically the initial three steps for relational database, semi-structured data, and the unstructured data, uh, when we are using the data factory as a pipeline, will be the same, because we are pulling we are using Azure data pipelines to pull data from the relational database, and we can use predefined schedule. We can also use a REST API as a part of your pipeline if you are using any SaaS software in order to push data from your SaaS application to Azure Data Factory. Second step is from the Azure Data Factory pipeline, you push this data to Azure Data Lake Store uh, generation 2, so that all your relational data is copied to a data lake. The third step is you use Azure Synapses Polybase capabilities for ingestion into your data warehouse tables. And the fourth is you load relevant data from Azure Synapse data warehouse into your Power BI data sets for the data visualization. Now and then means your business analysts or Power BI users or power users can analyze that data and have a look at those dashboards and reports. Now this was specific to relational database. Now when we go to semi-structured database as a data source, then you can use CSV, JSON files. You can connect to NoSQL database such as Cosmos DB or MongoDB. You can also use REST APIs provided by SaaS applications, and that will function as your data source for the pipeline. Then you move your data to Azure Data Lake, and then you use Azure Data Factory mapping data flows, or you can use Azure Databricks notebooks uh, for to process the semi-structured data and apply the necessary transformation. Then Azure Synapse Polybase capabilities to bring your data into your data warehouse tables, and then you can load relevant data from Azure Synapse data warehouse into your Power BI data sets for data visualization. Okay, now for non-structured data source, so we discussed about relational database, semi-structured data source, and now the non-unstructured data source. So you can consume videos, image, free text log from file-based locations. You can use REST API if you are using any SaaS application, and that is functioning as your data source for the pipeline. You can move your data to Azure Data Lake, and you can invoke Azure Databricks notebooks from your pipeline to process the unstructured data. The notebook can make use of cognitive services APIs as well, or you can invoke custom Azure machine learning services models to generate insights from the unstructured data. Then you can use an Azure Synapse Polybase capabilities for the data ingestion into your data warehouse. Afterwards, what you need to do is again Azure Synapse data warehouse. Uh, you can load data from the Azure Synapse data warehouse into your Power BI data sets for the data visualization. You want to create data dashboards or something. Now the last one is the streaming part. So in the streaming, uh, we are using Azure Event Hubs to ingest data streams generated by your client applications. It could be IoT application, it could be sensors, it could be gadgets. The event hub will then ingest and store streaming data, preserving the sequence of events received. And that's very important. A lot of applications have a very strict requirements of preserving the sequence of events. And uh, and then so and then you have your consumers, data consumers or event consumers, which can then connect to the event hub and retrieve the messages for processing. You need to configure the event hub capture to save a copy of the events in your data lake. This feature is basically, as I discussed in the first discussion, is the cold path. If you remember from my previous presentations on big data architecture, that in Lambda architecture there are two paths. One is cold path, one is hot path. So when we are using streaming analytics, it is or stream processing, it is a speed layer and there is a batch layer. A speed layer is basically is used by stream processing, and the batch layer is basically, or a cold layer, it is used for batch processing, because it takes long time to process all the data. But if you are processing a subset of data, then you are using that speed layer depending upon your business requirement, and that is a Lambda architecture pattern. Okay, and then once you for a hot path, you are using a stream analytics job to implement a Lambda architecture pattern, and you derive insights from the stream data in transit. And you need to define at least one input for data stream coming from your event hub, one query to process the input data stream, and one Power BI output where the query results will be sent to. Now, as you can see, we are using so many components in this architecture: Azure Data Factory, Azure Data Lake, Azure Synapse Analytics, Azure Databricks, Azure Data Factory, Azure Cosmos DB, Azure Cognitive Services, Azure Event Hubs, Azure Stream Analytics, Microsoft Power BI. It does not mean that you have to include all of them in your architecture. I wanted to explain the whole architecture and all and all the methodologies like batch processing and or lambda processing as well as batch processing within one architecture using the using Azure Services product, and that's the reason I chose this one. But it doesn't have to be this complex unless your business requirement states this kind of need for this kind of architecture. Now there are certain alternatives as well, especially for the situations where device management, authentication, and provisioning is your business requirement. You may want to use Azure IoT Hub uh, over Event Hubs. Azure Data Factory can be replaced with Azure Databricks in certain scenarios if you want to use uh, execution of nested notebooks. Azure Stream Analytics, as you know, is the service responsible for processing stream data. You can also use Azure Databricks to perform same role through the execution of notebooks. Now, the Databricks was used to invoke cognitive services. In this case, you can make use of Azure Functions to invoke your Azure cognitive services from the Azure Data Factory pipeline. As you see, means there are different alternatives as well. When I explained this architecture, now I explain what are the different alternatives that you have when you are choosing a specific architecture, and you have to look at the cost considerations as well. So let me give you a little idea about how this is calculated in terms of pricing. So when we are talking about Azure Synapses, it actually what you are paying for is for your compute resources, because they are charged per hour, and you can scale or pause these resources on demand, and storage resources are built per terabyte, so your cost will increase as you ingest more data. Data factory costs are based on the number of read-write operations, monitoring operations, and orchestration activities performed in a workload. So your data factory cost will increase with each additional data stream and the amount of data processed by each one. Power BI has got different product options. It really depends upon what sort of offerings you have, or what sort of product licenses you have in your organization. But Power BI Embedded provides an Azure based option for embedding Power BI functionalities inside your applications. So you may want to include those aspects as well. If you have intelligent applications where you have Power BI embedded within application, and you want to make sure that the whole architecture is low cost, as well as you are delivering the right analytics, or the right data, or the right information to the right individual using the right applications or the right architecture, or I would say the best fit architecture, then Power BI Embedded is one of the options you may need to look at, especially from the applications perspective. But again, all of this, it depends on what is your business goal, what you are trying to achieve at the end of the day. But I guess this is it from my side. As I said, I explained almost all the parts and components of this architecture. You can take this one and tailor it according to your needs, and this is a good starting point if you are planning to implement Azure modern data warehouse, and you have a complex application architecture where you are using data streaming as well as unstructured data. So maybe this is a good starting point to take off from here, and then you can make adjustment based upon your budget, based upon what is the end product that your organization is looking at from the business perspective. Thank you very much for watching. Have a great day.